Okay, so now let us look at this series problem. And so given this series, and it asks us to figure out what is the radius and the interval of convergence for this series. And also what values of x does the series converge absolutely and conditionally. Okay. So for this actually is also a power series problem. And then to start with, we often like to use the ratio test, and to figure out what value of x converges, and also from the first conclusion of ratio test, that is, if the ratio is less than 1, and then it not only converge but also converge absolutely. Okay, so to start with, let's start with the ratio test. So ratio test, and our an plus 1 over an, absolute value, you're going to have is negative 1 to the power n plus 1, and 7x plus 3 n plus 1 over negative 1n, 7x plus 3 to the power of n, absolute value. Okay. Of course, after we got this, turns out we can omit those alternating terms because we have this absolute value sign. So all we have here is this. Okay. And we know that if this ratio, denoted as capital L, if capital L is less than 1, then series converges absolutely. Of course it converges. So what we can get is, we solve for this inequality, that is less than 1 greater than negative 1. And it turns out, and then I get this. Okay, so you see that inside this interval my series converges, but one of the outside of this interval, we have to test at the endpoints to see if the series converge or diverge. So when x equals negative 2 over 7, so my series becomes into 7 times negative 2 over 7 plus 3 to the power n. And then if you simplify this part, is minus 2 plus 1 is 1. So you're going to have this series, which is negative 1 to the power n. Okay. And based on the nth term test, since limit negative 1 to the power n does not equal 0, and then we can claim that actually this series diverges. Okay, diverges. Okay. And then we can test the other endpoint, which is x equals negative 4 over 7. So plug in, we're going to have 7 times negative 4 over 7 plus 3 to the power n. And keep in mind, after simplification, this part is going to be negative 1 to the power of n. Okay, so we have negative 1 to the power n times negative 1 to the power of n. Turns out this is going to be 1 to the power n, which also can be written as 1, right? So you have 1, 1, 1, plus 1, infinite many ones adding together. And of course, based on the nth term test, we can also claim that at this endpoint, it also diverges. Okay, it also diverges. So a couple of things. So after here, guys, basically we got pretty much we got everything what we want. So the interval of convergence, okay, for this is it's going to be from -4/7 to -2/7, and also the radius of this convergence. Actually, all you need to do is you calculate the length of this interval and then divide by 2, right? So that's gonna give -7/2 minus -4/7, and then put parentheses here, right? This is the length of the interval, and then half it. So it turns out you're gonna have 2/7 inside of this bracket, and then half that. So the radius of the convergence is 1/7. And of course, the when x is between -4/7 to -2/7, series converges absolutely. Okay, absolutely. And we also testify that also at the endpoint it diverges, so that when x is greater or equal than -7/2, or x is less or equal than -4/7, series diverges. Okay, diverges. And also, we don't have any value that satisfy the condition of convergence conditionally, because the idea of the convergence conditionally is the series itself, it converges. However, the absolute value, it diverges. And we checked that we don't have any x satisfy that. So there is no, and also there's no value of x converges conditionally. Okay, conditionally. So that's actually solved the whole problem here. And okay, so again, the central idea is to apply ratio test and then test at the two endpoints, because think about if one of the endpoint it converges, and then we can get the conclusion that actually at those endpoints the series actually converges conditionally, right? But in our problem at those two endpoints, the series both diverge, so that eliminates the possibility of being convergent conditionally. Okay, so hope you enjoy this video, and thank you for the watching.